Now, the top view capital PQ of a straight line is 70 mm and makes an angle of 60 degree with XY line. The NQ is 10 mm above HP and 30 mm in front of VP. The difference between the distances of capital P and capital Q above HP is 45 mm. Draw the projections and determine its true length and true inclination with HP and VP. So here NQ is 10 mm above HP. So when you look from the front view, we can see the distance NQ, which is above HP by 10 mm. So when it is projected, so it will going to fall on the vertical plane. So that distance is 10 mm above HP. So you mark this point as Q dash. And 30 mm in front of VP. So this is the distance in front of VP. So when you look from the top view, you can see that projected onto the vertical plane in the horizontal plane, so that you will going to get that distance on the horizontal plane. So that is 30 mm in front of VP. Then the top view capital PQ of a straight line is 70 mm and makes an angle of 60 degree with XY line. You mark this point Q. So since he says 70 mm with 60 degree with XY line, from Q you draw by using the protractor you measure an angle of 60 degree and draw a inclined line, and by using the compass you take this distance and 70 mm, cut an arc on this, you are going to get small p. So now since it is small pq, so you are going to get this the top view. So this will going to be pq, draw a line which is with a dark line, which is pq. Now we got the locus of q in the top view. Then he says the difference between the distances of p and q above hp is 45 mm. So we know that distance above HP is 10 mm. The difference in the distances, that means from this line to this line the distance is 45 mm above HP. So from this point, usually we measure from the XY line, but here since he says the difference, so you have to be careful here. So you should not be taken 45 from the XY line, but here it should take from the 10 mm above HP line. You have to take the distance of 45 mm and draw a horizontal dash dot line, which will going to be the locus of Q in the front view. So since we have the top view, so from this point we know that the front view will also lies on the same line, but and you have the front view locus. So from P you draw a vertical projector to the XY line, and then again you project from here to here, so that you will going to get this point, which will going to cut the locus of P in the front view. So you mark this point as small p dash. Then dark between P dash and Q dash, which will going to be the front view, and dark between Q and P, small p and Q, which will going to be the top view. Top view. So now we will go to, so since we need to find out the true length in the vertical plane first. So when you are projecting this point here from small p, when you are projecting upwards, and from P dash you are projecting in the horizontal direction, so that you will going to get this point capital P, then join Q and P with a dark line. So this will going to be the actual length of the line in space. Now when you want to find out the true length in the vertical plane, you make this QP parallel to VP. So with Q as center, take the radius of QP, draw an arc such that QP1 will be in front of VP by 30 mm. So then this line will going to be parallel to VP, and when you are projecting that onto the vertical plane, when you are looking from the front view, so that is projected onto the vertical plane, so that you will going to get this point P1 dash here and Q dash is here. So you are going to get this true length in the front view. So this is the inclination with respect to HP. But what happens in the horizontal when you look from the top view, that on the top view line QP is rotated such that P1 and Q will be in front of VP by 30 mm. And when you are projecting this, you are projecting in space like this onto the vertical plane. So here the image, when you look from the top view, that image will going to be this line. It will come to the XY line, and when you look from the front view, it will be this vertical projector which has been drawn such that it will going to cut the locus of P in the front view. So since this is the top view and this is P1 dash is this front view, so you're going to get this point. Then join Q dash P1 dash with a little bit thicker than the projector line. So this will go to be the inclination and determine the true length here, which will go to be found out. Now similarly, we want to find out the true length in the horizontal plane. So here with Q as center, take the radius of QP, draw an arc such that Q is above HP by 10 mm and P also above HP by 10 mm. So that means when you look from the front view, both Q and P2 will be above HP by 10 mm. Therefore, the line will going to be parallel. And when it is projected in the top view, so that will going to lie on QP2. P2 will going to be cutting on the locus of Q in the top view. So now this will going to be QP2 in the top view. That inclination made by that with respect to VP is phi. But when you are looking from the front view, the image will going to be on this, which will going to be the P2 dash. So that from Q dash P dash you draw an arc such that it will go to make parallel to HP, because we are rotating from here to here. So when you look from the front view, the arc will going to be start from Q dash P dash and then draw an arc such that both Q dash and P2 dash will be above HP by 10 mm. And then since you are projecting this down here onto the horizontal plane, so that image when you look from the top view, it has been projected here, front view is projected here. Then when you look from the top view, so this is the direction of projection. So from here, this will going to be the direction of projection, which will going to cut the locus of P in the top view. So and join QP2 with a little bit thicker than the projector line. So the inclination made by this will going to be the phi. So this is how we will be able to solve the problem in 3-dimension analysis, which we can be done. Now we will going to solve this problem in sketchbook. First we will going to draw the XY line and mark XY and VP HP. So he says Q is 10 mm above HP and 30 mm in front of VP. So from the XY line you measure 10 mm above HP, that is above XY line, because distance above HP is seen in vertical plane. So vertical plane is above XY line. So you mark the distance and draw a horizontal line. Then the 30 mm in front of VP, from XY line you measure 30 mm in front of VP. In front of VP is seen in HP. HP is below XY line. You measure the distance below XY line and draw a horizontal line. So then taking any point and draw a vertical projector, so that you will going to get this Q dash here and small q here. So now then the top view makes 70 mm and makes an angle of 60 degree with XY line. From Q, by using the protractor you measure an angle of 60 degree and draw an inclined line. By using the compass, take 70 mm with Q as center, cut an arc on that 60 degree line, so that you will going to get this point P. Then since you get the point P, so this will going to be the locus of P in the top view. So draw a dash dot line here and join Q and P with a dark line. So since we have and also the difference between the distances of P and Q above HP is 45 mm. So we have above HP by 10 mm, and the difference is that from here it will go to be 55. So that the distance between the difference in the distance between this 55 minus 10, it will go to be 45. So in other words, you measure from here, you take 45 mm, draw your dash dot line, which will go to be the locus of P in the front view. So since you have the locus of P in the front view and you have this top view point, so draw a vertical projector from small p, so that it will going to cut the locus of P in the front view, so that you will going to get this P dash. Then join Q dash P dash with a dark line. So this will going to be the front view and this will going to be the top view. Now we will first going to find the true length in the vertical plane, so that you are going to make the line parallel to VP. The line which is inclined to VP is the one which is to be made parallel to VP. With Q as center, take the radius of QP and draw an arc such that both QP1 will going to make parallel to VP. So that is what we have done here. Q with P, which is rotated, so that QP1 is made parallel, that is QP1. So Q is in front of VP by 30 mm and P1 is also made in front of VP by 30 mm. So that this QP1 line will going to be parallel. So its front view will going to be in true length. So from here you draw a vertical projector, which will going to be cuts the locus of P in the front view. So you are going to get this point P1 dash. Then QP1 is the line which is parallel to VP. So you are going to get the true length here. So you mark this as capital Q and capital P. Then join Q dash and P1 dash with little bit thicker than the projector line. So denote this angle with respect to HP, which is theta. So we will going to measure the angle later. Similarly, so we need to find out the true length in the horizontal plane. You make the line which is inclined to HP. You make that line parallel to HP. So that is what we have done here. Q to P, rotate that P such that P2 will be above HP by 10 mm and Q is also above HP by 10 mm. So when it is done, so when you look from the front view, the image will going to be from here to here, which has been rotated. So with Q dash as center, by using the compass, measure the distance from Q dash to P dash and draw an arc such that P2 dash is above HP by 10 mm and Q dash is also above HP by 10 mm. So now Q dash P2 dash is the line which is parallel to HP. So when you are projecting to the top view, so Q is here and P2 will going to be cuts the locus of P in the front view, which is P2 in the top view. So join Q and P2 with little bit thicker than the projector line. So denote this angle as phi. So by using the protractor, you measuring the angle with respect to HP, which is theta, which will be 32.74 when you are doing it in computer. When you are doing it in CAD, when you are doing it in manual, it will be 33. And by using the protractor, you measure the angle with respect to VP, which will going to be phi, which will be 47 degrees when you are doing it in manual. When you are doing it in computer, 46.76 degrees. So by using scale, you measure the true length in both HP and VP, which is going to be same, which is 83.22 when you are doing it in CAD. When you are doing it in manual, it will be 83 mm. So and show the dimension. So this is how we will be able to solve this particular problem. So now we are going to analyze it stepwise. So first here, we draw the XY line and take the distance above HP and also distance in front of AP, and you mark this point Q dash and Q. Then difference of distance above HP is 45 mm, so you mark the front view locus. So we have the top view point and 70 mm, which inclined at 60 degrees. When you draw this, you are going to get the locus of P in the top view also. Then you know that this is P, top view. Then the distance between the end projectors will always cut the locus. So you draw a vertical projector from P to the front view, so that it will going to cut the locus P in here, P dash. Then join P dash Q dash with a dark line. So then you make QP parallel to VP. So that is what we have made, QP you made parallel to VP. So that QP1 will going to be the line which is parallel to VP. When you look from the front view, you are going to get the true line. So that is what we have made with QP1 made parallel. When you are drawing a vertical projector to the front view, you will going to cut the locus of P in the front view. So you are going to get this P1 dash. Then join Q dash P1 dash here. So here, since this line is parallel, so you will get capital P and capital Q. Then measure the inclination theta here and also the true length. So that is what we have done in the first step. So in the second step, so we have taken the front view and then we have found out the true length in the horizontal plane. So you make this line Q dash P dash parallel to HP. So Q dash is above HP by 10 mm. P2 dash is also above HP by 10 mm. That is what we have done. We have rotated P such that P2 and Q both are above HP by 10 mm. So then when you look from the top view, you are going to get the true length here. When you look from the front view, the image will going to be here. So we are projecting this line here and this distance here. So that is how you are going to get the true length in the top view. So once you do that, Q dash P dash is parallel to HP. Now when you are projecting this point onto the locus of Q, you will going to get this small P2. So this is the line which is going to be the true length. And why this is capital Q and this is capital P? Because this line is parallel to HP. So you are getting the true length in HP. So identify the angle phi and measure that angle. So this is how we will be able to solve the problem.